Hi and welcome to chandu.org. I am Today I want to talk about why you should avoid complex, convoluted sum product and go with something simpler like a pivot table or power query driven data cleansing and reshaping whenever possible. Recently, there is a forum. I think it was a forum question that has a typical timesheet data, and then the user wanted to understand how many hours each of the employees have spent, and calculating that using a formula is possible, but the formula driven approach can be very complex because of the way the data is laid out. So I'm going to show you both formula and Power Query driven solutions for that, but first let me just show you where I am. Today is almost a clear day in Wellington. We are already in winter. Winter is usually in June, July, August months in this part of the world, and I thought of taking a break from cycling, so I started doing a bit of walking around. And today I walked up to mm, Mount Kaukau, and I plan to continue my journey towards Makara Peak and then get into the city. So it's about three hours or 4 hours walk, or maybe even 6 hours. But I don't want to walk for 6 hours. I hope to finish before that. But first, let me just show you the beautiful views here. You can see the city behind me in the background there. That's the city. You can see that there is a bit of sunshine there, and this is Makara Peak. And then there is a giant TV tower, the Korea TV tower, that is in the back, uh, and if I turn this way, uh, far in the horizon, you can actually see South Island of New Zealand there. I'm not really sure if you can make it out in the video, but it is there. And in winter, usually the days are really clear, and you can actually see some of the mountain peaks and even snow on them in Southern Ireland. And yeah, it's a really beautiful place. And every time I walk up this track, I'm like amazed by how much beautiful it is. And today is extremely clear, and there is no wind. Just to prove your point, you can see the windmills in the background, and they're all static. They're not moving, and that's quite unusual because the windmills are positioned in the wind tunnel. That's where usually most of the wind flows through into Wellington, but none of the windmills are moving, so it's an extremely quiet day for this. So I'll continue my walk, and when I finish my walk, I'll go up to home and resume recording this video with a screen capture of the solution with Sumproduct and Power Query driven approaches. Thank you. Bye bye. Hi and welcome to chandu.org. In this video, we are going to take a look at a typical data extraction and summarizing problem and understand different approaches, both formula driven approach and Power Query driven approach. As I mentioned in the intro video where I was on Mount Kaukau, and I did continue the walk, but I got lost. It's the tracks are usually fairly well marked in Wellington and probably anywhere else in New Zealand too, except you get into deep forest. But because there is a bicycle track as well, which is quite wide, at a junction, I mistakenly went onto the bicycle track, and then I got lost in the hills. And I almost walked like 3 kilometers into the hills before turning back because I couldn't see anything else. Like there's no yellow markers to say the track, and my GPS kept on telling me that I'm on the right direction, but I couldn't find any way to the Makara Peak. So I turned back, and then I went back to the junction, and then I continued the walk. So it was supposed to be a 12-kilometer walk, but I ended up walking 16 kilometers and not even reaching the destination. And I was getting close to the school pickup time, so I had to get down the track and catch a train back home so that I could pick up the kids in time. Well, all in all, it was an interesting day, and far better than juggling with Sumproduct or even Power Query for that matter. But let's talk about the problem here, which is here is a typical timesheet data, and as you can see, we have in timesheets you usually have like a 7-day template. Sometimes you can also have a fortnightly template, but usual thing is to have a weekly template. So you have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then this particular timesheet is for, it looks like it's for a hotel chain. So you have different hotels, and then each hotel has different positions. You have a lead, receptionist 1, 2, and then 3 different shifts in the day. So you have first shift, second shift, and third shift. And then who is the employee that's being in? For example, on Monday, the lead is filled by employee number 1, who started at 5:30 a.m. and then ended the shift at 1:30 p.m. And the data is filled in like this. Presumably, this is the kind of data that is entered by staff or a hotel manager on weekly basis based on who is doing what shifts or who has done what shifts. And as an analyst or as someone who is running payroll or any other kind of things, you would like to know how much time each employee has put in, how many hours. So here is one formula that they have done, but this is actually, this is only showing the number of shifts done, not the actual hours. So this is actually showing number of shifts. So the question that is posted by the person who asked this in the forum is that I could calculate how many shifts each employee attended, but I want to know how many hours each employee has put in. And that was far more complicated than it sounds, because if I want to just know how many shifts employee 1 has done, all I have to do is in this giant range, the 721 column range, because 7 days each day with 3 columns, I have to just find how many times employee 01 occurs. Whereas if I want to find out the total duration done, then I have to find out all the occurrences of employee 1, look at the adjacent columns, start and end times, subtract the end time from start time to calculate the total hours, and then add all of them up. Now there is no simple formula in Excel to do this, so what some of the ninjas on our forum has done is they have arm twisted Sumproduct formula to get the answer. Let me show you what some of the answers are. Like Hui, one of our forum ninjas, came up with this beauty of Sumproduct, which I don't want to explain this because it could take like 15 minutes to explain this whole formula. But if you have been into the Sumproduct rabbit hole, then you could see what's going on here in a way. Like what he has done is, in a nutshell, start from column C and go up to column U, only that range, because that's where all the employee names would be, and then create 2 more ranges. This is one that starts from the first start time and ends at the last start time, and then that's the third one. So 3 ranges, basically like moving ranges, one starting at column C, D and E. All of them have same size, and where there is an employee 1 match, he takes the end time minus start time and then multiplies that with 24 to get it in hours, and then does something and using if error to handle the cases where there is no valid times. And then a few others came up with some other formulas. Obviously there was a problem. I have noticed an error in the formula, because what we assumed is that the end time will always be more than start time. But what happens is, if a shift starts before midnight and ends after midnight, by definition Excel times would look like the end time is less than start time, because you just enter only time value in the cell. So that requires some additional handling of that scenario. And then John Gyro, another forum member who is extremely good with formulas, came up with this beauty, which is a sum formula, not a Sumproduct, but essentially it's the same. And this one using mod to give the answer. But I kept thinking, because I could also come up with some formulas to answer this, but I thought, what if we could altogether eliminate the problem, and if we could restructure this data? For example, if the data is in this shape, hotel, location, and then post, and day on which the employee start and end time. So these are times, they are only showing up as numbers because dates and times are numbers in Excel, but if you format, then you should see this as time. If only the data is in this shape, then we could easily calculate the duration. Duration is nothing but end minus start, or if the end happens to be less than start, then we add 1 to the end time and then calculate the difference. So a simple if formula would give me the answer, and then I could just add a pivot table on top of it to see what's the total duration by each employee across all the timesheet. This approach would be far better than the Sumproduct approach, because if we could somehow reshape the data into this, then if I have timesheet files like this spanning an entire year, so that means I have 52 files, I don't have to set up 52 different formulas in each file. I can just transform all the data into this, combine all of that into one file, and then pivot it. I know you can already guess where we are going with this. We are talking about Power Query here. So to use Power Query, I'm just going to show you approach with one file, but once you know the approach, you can apply it to a set of files. Let's say you have timesheet files in a folder, each named with the start date of the week, or like week 1, week 2, like that. And these files could be CSVs, Excel files, it doesn't really matter. It works beautifully if they are even CSVs, but it shouldn't really matter. So if they are like that, then we can do it. We can just automate the entire folder, collect all the data, and then reshape everything and merge everything into one giant file. And then using pivot tables, you can calculate how much time each employee has put in on weekly basis, monthly basis, or all the year, or whatever. So that could provide powerful answers without having to do a lot of mental gymnastics with the sum products or array formulas. So how would you do that? One of the things that you need to keep in mind is, when you want to transform your data with Power Query, your data needs to be mildly in shape. It doesn't have to be fit and perfect. It can have a lot of useless values and poorly formatted stuff thrown in. That's fine, but certain things are too hard to work with. For example, these two cells are merged, and that can create a lot of problem. So what I have done is, the only transformation that I have done here is unmerge them. Okay, that's why I said if they are CSV files, that's even better, because in CSV files you can't have merged cells and all of that. These are not merged, they are just looking like merged, but they are just values on the top cell. So if they are text or CSV files, that's better. But so what I did is, I didn't want to try mess up with this layout here, so I copied the whole thing and pasted it into another worksheet, and then I have converted that into a table with the option of no headers. So table, when you convert that into a table, Excel would add its own headers with the column 1, 2, 3, 4, 5, like that. And as you can see, there is no merging here, so the second row is empty, the first row has that. So let's just live with this format, and once the data is in a table, we could load that into Power Query. If it is just raw data as a CSV, then you can directly load it into Power Query, but otherwise, if it is in a range, then you must first convert into a table before you can put it into Power Query. So once it is in a table or tabular format, you can go to data and then from table. Okay, then this opens Power Query window, which I'm going to minimize and resize into the recording area. I have already done the transformation as a separate query, but for this lesson I'm going to show you all the steps from scratch. And when you download, you would find 2 queries in the workbook. So go ahead and play with them. If you want, you can give this a name like timesheet, and the very first thing that we want to do is we want to sort out the headers. They are somewhat messed up, so what I want to do is select the first two columns, and these rows are null, so I want to fill them down, or maybe I'll do it the other way. We'll select these two and then we will fill them up. By that what I mean is the start and end words would also be filled up into the null cells there. So you select these two and then we go to transform, fill up. So this will, wherever it is null, it will fill up. Obviously these things won't be null. Even if they are null, they will be filled up, and it doesn't matter because we only care about places where there is an employee name. So once you do that for Monday, then we have to repeat that for Tuesday, and Wednesday and Thursday and Friday. You don't need to do this one step at a time. You could use Control to select all the columns and do it. It'll be same. Power Query will, in fact, if you notice, it's not adding up any steps here. It's just using the same fill up step and expanding the definition of that step to include all these extra column names. So we have done that, we have filled it up, and then now the next thing that I'm going to do is I'm going to promote this column as the header. Okay, so we don't need to select anything. We just go to home and then say use first row as headers. Then that's done. This row is irrelevant, so I'm going to delete the row, remove rows, top rows, and number of rows 1. So that's deleted. Now we have mildly reshaped the data, and all of this gymnastics we had to do because of the inconveniently formatted input data, which has 2 rows of header with the merged situation that is going on there. With a little bit of smarts, when you're collecting input data, you could probably even avoid those steps, but let's just say that's what we are inheriting, and we don't want to waste any more time cleaning up the data. So these steps we are doing. Now remember, all these steps are one-time things. So if you have, let's say, 200 timesheet worksheets, you do this only once, and then you ask Power Query to run this process on all those files, because assuming all of them have the same kind of crappy format, Power Query can just massacre all of them and reshape them into the way that you want. So these steps, although they look like they're manual things, you are essentially setting up the definition for cleaning up the data, and next time you have a new timesheet, you just run the Power Query and it will apply these steps automatically for you. So that's done, and the next thing that we want is, if you look at the structure of data, we have, for each day of week, we have 3 columns, and what we need to be doing is we want to take these 3 column sets. So we have 3 column sets of 7, and move them one under another. So the first 2 columns should remain as they are, and these 3 for Monday, and then the Tuesday will go down, Wednesday, Thursday, like that. So we want to transform it kind of like a pivot table, but not exactly like that. So it's somewhat tricky to explain what we want. You have seen the output format that we want, and then once that is reshaped, we want to remove all the nulls, so that only the rows where we have some pertinent information, that is timesheet information, entered, we only keep that. Okay, so how do we do that? So this is where a little bit of Power Query trickery comes into picture. What I'm going to first do is select these 3 columns, the Monday ones, and I'm going to transform and then merge. So I'm going to merge these 3 columns with a comma separator. You have to pick a symbol that is not usually found in this data set. It looks like it's names and times, so comma seems to be a fairly good one, and the name for this new column can be Monday. This is the merged values for Monday. So we get that. We have to repeat this step for all the 7 days. Tuesday, So okay, I have added the merged values, merged columns, um, and then this is what we get: Monday 1, Tuesday. Power Query is naming them as Monday 1, Tuesday 1. That's because the original data already has Monday and Tuesday as column names. So uh, in order to not conflict things, this is what it has done. So now that it is in this shape, this kind of looks like a pivot table with the location and post as the row label values and then Monday, Tuesday, Wednesday, Thursday, Friday as the pivoted values. But not exactly pivot table, because pivot tables don't usually contain text values. They're just numbers. But nevertheless, what we now do is we select the first two columns and then we say unpivot other columns. Okay, what this does is it will reshape this data so that you will have this kind of an output. So location, post, and then this is attribute. Would be, let's call this as day, and then value. Value is where the merged value is appearing. And now what we want to do is anything that doesn't have an employee we want to get rid, because that means on that day, on that shift, for that position there was no employee, so there is really no need to have that information in the output. If you want, you could keep it, but otherwise for this particular task where we want to just sum up the number of hours, it's irrelevant, all this information. So what you can do is you can go to this and there's a remove empty button, but that's not going to help us. So we want to go and filter anything that does not begin with so we want to just keep anything that does not begin with a comma. That means the first value is null, so all of these guys will be removed. So that does not begin with comma, and then this is what we end up with. And then we select that and we now split it, because this is not the format we want. We want employee, start, and end time. So we'll split by delimiter as a comma and then click OK, and it will split that. So this is your employee. We'll just rename the columns, start and end time. So now that that's done, if you want, you could go ahead and do a bit of formatting here, but it's not necessary. For example, if you want, you can select these two and change type to time. Yep, that sounds all right. And if you want the day of week to be actual day of week, not like Monday.1 or something, you can do a replace values with .1 to be replaced with. So those are gone, and this is the final shape. This is the actual query definition. So anytime you have a new timesheet, you change the data, you refresh the query, and you will get a new table that contains different rows. So that's it. We just close and load this into Excel. This will come up and sit as a table in a separate worksheet, and there you go. You can now go ahead and summarize this, or you can even add a new column with this table. If you're planning to add a column that tells how many hours each employee worked, I would suggest adding that at Power Query level, not in Excel, so that your Excel output is pretty much what you need, and then you could go ahead and pivot it, but no harm. For example, I can say duration, which is going to be end minus start. That's a very layman definition of duration, but if you want to incorporate the condition of shifts beginning at the sometime before midnight and ending after midnight, then so we will simply say if end is less than start, then we want the 1 plus end minus start. In the other case, it's end minus start. This is not the most elegant formula to tackle that situation, but you know, it does work. So that's the duration. This is the duration in as a portion of day. If you want it in hours, then you just multiply this with 24 and then you will get the duration in hours. But there you go. Once you have it in this shape, you could quickly answer how much each employee did by either writing a sum ifs or pivoting this data. And if there is any change, for example, if you have an employee on this for, I don't know, employee 02 doesn't want to work because I think there's some data validation here. Maybe I can go and see what the data validation refers to an external range. That's why there is a hash ref error. So probably I'll clear the data validation rules and then employee 02, employee 03, and then Chandu U. So we enter some random data like this, and then if I go to my output and if I refresh my connection, we should get those names here nice and quick. So this is very powerful, very elegant, and very smart and easy way to deal with this problem. Of course, it is significantly longer than writing the sum product formula. Probably if you are familiar with the sum product and have done a little bit of array formula wrangling yourself, you would find that writing that kind of a sum array sum product or sum formulas would probably take like 3-5 minutes time, whereas the Power Query approach has taken good part of 15 minutes, and that's because I'm explaining. But if you do it yourself, even figuring out the logic for transforming from this kind of a shape to that shape, it might take a while. Like I had to try different approaches before hitting on the merge column and then split column one that we have used for this. But nevertheless, I see this as an investment, because once you do this, you can then apply it to this shape of data, because it seems to be the standard in this case. So doing it through Power Query is definitely what I would recommend. So thank you so much for watching this video, and thanks for putting up with my sad story on the hill. Well, it's not really sad. I had lots of fun, and I got a little scared at some point when I got lost in the hills, but throughout that thing I had my cell phone reception and 4G connectivity on the phone, which is surprising. But of course I'm on the hills, so you'd find that maybe cell phone signal would be easy to acquire there. And yeah, thanks so much for watching the lesson. I hope you enjoyed it, and talk to you soon. Bye bye.